Hello and welcome to part 2 of the Mastery Bootcamp. My name is Jeffrey Mays. In part 1, we talked about the Cram-Pass-Forget Cycle. We talked about the problems of students frustrated with inherited methods that don't work, about being uncertain about what they're accountable for. We talked about lowered expectations and how accountability ends after the quiz or the test. And then we talked about the results of a stressful exam week, of forgetting what they've learned just shortly after an assessment, and then how they become like bored tourists and cynical with school. And now we're going to go on and talk in part 2 now, out with the old Cram-Pass-Forget cycle and in with a new learn, master, retain paradigm. I want to ask you a question before we get started. Can you think of subjects where it is known and assumed, perhaps subconsciously, that Cram-Pass-Forget will not work? Some people might say mathematics, some would say music, athletics. Two of my favorites are foreign languages. In French class or Spanish, you can't just, when you're done with chapter 3, go on and forget the vocabulary. And in doing chapter 4, another example is driver's ed. Imagine if students just learned the meaning of those traffic signals for the test, and then they passed the test and then started forgetting all the traffic signals. That would be a disaster. I think we can all agree. So you may be thinking that this is a little too good to be true. If this is true, maybe wouldn't I have heard of it before? Wouldn't someone have thought of it by now? I don't know. I can't explain that, but I can tell you that there are common sense methods that I'm going to talk about now that are not being talked about. They may have been thought of, but they're not being used. But they will transform your students' experience in science, and if transferred to other subjects, will transform them too. These principles apply to both homeschool and brick and mortar schools. So let's begin. First things first, what is mastery learning? I define it as long-term retention, plain and simple. Okay, long-term retention. There are the word mastery, incidentally, gets thrown around these days. It's been used for several decades, and different educators mean different things by it. One example we heard of that was that students have to keep taking a chapter test, until they make a 95. 95. And that they don't, they have to retake it. And the teacher might have to make a new test even, but they just keep taking it over and over and over. This may be a kind of mastery. I don't know, but it's brutal. It's kind of, it's near perfection, requiring near perfection, which this is a kind of a hamster wheel mastery. We want better education, but we don't want cruelty and insanity. And I'm not even really sure that such a 95 standard would affect real mastery anyway. Not in this sense. Not in the sense of long-term retention. It just makes students work harder, and it raises the bar. Yes, but raising the bar is not the goal here. The goal is long-term retention, all right? Let's be clear about that. We're not just trying to raise standards. We're talking about making kids learn and retain long-term. So throw out that, raise the bar. When it comes to education, that's not the goal. The goal is retention. All right. We want students who you can bring back in December and take that test from the previous year in December and still pass it. Not even just 6 months, but 2, 3, even 4 or more years later. Long term. So let's talk about mastery. What are some essentials? All right, the first essential is cumulative assessments. Cumulative assessments. This is the cornerstone, the crown jewel of mastery learning, if you will. It is so important that I'm going to come back to it later and give you instead a few supporting concepts. The first thing is we're going to cull down that huge curriculum, no superfluous content. All right. This is another way of saying the old mile wide and an inch deep phenomenon. I hear teachers say sometimes that we're going to cover a lot of stuff, and some of the stuff we're really kind of skim over it. We're just gonna talk about it briefly, just so that they'll have a mental hook, so that when they hear about it later, it won't be completely unfamiliar. And this is well-intentioned. As I said in part one, teachers said, I know you have good intentions with this, but I'm going to tell you that this is a waste of time. I call this hit and run instruction because it does not affect learning. It doesn't affect mastery. It's just a myth that we tell ourselves that this is how learning works. I say, let them learn it properly in the future when they encounter it. There's not really a great benefit to touching on it now, just covering it now rather than mastering it now. Okay, now there is truth to the idea that multiple encounters with content will result in better learning. That's true. In fact, it's what Novare is based on. But it's not what's accomplished by hit and run methods. Next, we're going to eliminate busy work, and every assignment is going to support a specific learning objectives. Busy work. What is that? We all know that that's a derogatory word, right? Nobody wants busy work. Well, what is it? Busy work is work that is simply an assignment designed to give students something to do, something to keep them occupied, something that you can grade and therefore assign a number and give the student a grade. It's all about the machinery of education, but it's not about learning. Okay? Exercises have to be tied to a specific learning objective. And worksheets are not specifically in themselves the problem, but the kind of work you typically do on a worksheet it's just almost universally bad pedagogy. Multiple choice questions, matching, fill in the blanks, these are a very cursory interaction with the content. They do not foster learning and retention. They foster an attitude of getting it done so we can move on. So we're going to eliminate busy work and replace it with, well, I'll tell you in part 3. Next, time spent reviewing and rehearsing occupies 30 to 40% of total weekly time. Now, this is the time that you're at home. This is at-home time, sitting at the kitchen table, doing your homework, reading the textbook, whatever. And I'll just say as an aside here, everyone needs to do their homework. Kids need to do their homework at the kitchen table. Get them out of their bedrooms and in a place where they don't have a computer or a TV or a radio. There are some subjects you can do with a little music on in the background, but you have to have discretion there. But I say get them down to the kitchen table and out of their bedrooms. Parents, that's important. Anyway, they need to be spending about a third of their weekly time reviewing. Now, I said that cumulative assessments was the cornerstone earlier, but if I could have a second cornerstone, it would be this one. Okay, students rarely do this. They're not very good at reviewing, but that's what they need to do. I want to say a word quickly about flashcards. You see flashcards right there. Kids do not know how to do flashcards very well unless they're taught. So teachers, parents, show your kids how to make good flashcards. You don't need a 4x6 index card for a tiny bit of information. Show them how to cut them down to size like that so they fit right in their palm. They put a rubber band around it. You write the thing on the front and then the answer on the back, and then you teach them. You tell them, how do you do this? Well, when you get up in the morning, you put your keys and your wallet in your pocket, and then you put your flashcards in your pocket as well. And when you're standing in the lunch line, or when you're in your car at a stoplight, or when your mom's driving you on your way to swim practice or whatever, you take out your flashcards and you go through them. You don't listen to the latest radio blasting. You buy up that time, those extra minutes. Now this is where efficiency comes in, parents and teachers and students. This is where it's good to be efficient. Use the time you have wisely. I'm sorry if you heard my dog there in the background. Okay, so what you write on here, you got the formula, right. Okay, other things that are good for flashcards are vocabulary, vocabulary words. There's a few of them, and there's some just have to be memorized. There's no way around it. Some formulas that there's no other way around it. You just memorize them. They're not that complicated, really. Historical data can be put on a flashcard, that kind of thing. All right. Finally, key skills embedded throughout the curriculum, and we're going to embed lower level skills in higher level exercises. So what am I talking about here? On your right hand side, you see a close-up shot from a high school, a ninth grade physics textbook from one of our Novare textbooks right there. Up at the top, you see the first thing is 1.67 times 10 to the minus 18. Okay, what do we call that? You remember what we call that, parents? That is scientific notation. Okay, that's something that's learned back in about the 6th grade, maybe earlier. Exponents, that's pre-algebra. And scientific notation is pre-algebra. Next to that is a Greek letter mu with a little g. Anybody remember what mu stands for? Mu is the metric prefix for micro. So that's micrograms. Below that, NS, that stands for nanoseconds. Below that is capital G, capital N. Capital G is for giga, and capital N is newtons, so you have giganewtons there. Below that is gigagrams, and then at the bottom, centimeters per second. So what we're illustrating here is these are basic skills. These are elementary school level skills, or maybe middle school. Learning the metric prefixes is a one-day thing. You can be assigned on the first day of school in the 7th grade or something, and you just learn it. And then if you use those every day, they're going to stick. And same with scientific notation. It's a lower level skill, but this is a 9th grade textbook. And so in Novare textbooks, for one, at least in our books, we're going to assign these oddball, unusual units. The question will include unusual units, and then they have to give their answers in standard units. Kilograms, meters, that kind of thing. And you can do this with lots of different skills, with unit conversions, if you're going from miles per hour to meters per second kind of thing. Other types of algebra manipulations, isolating variables, for example. You can do this with calculating percentages, significant digits, for frequent use of easy formulas that they learned in 5th and 6th grade, like calculating area, perimeter, volume. You can do this for repeated use of vocabulary and accurate use of vocabulary, computing averages, and so on. There's lots of ways to do this. So this is the end of part 2. Join me next with part 3, where we're going to go a little deeper and talk about additional principles for mastery learning.